Hello, we're going to have a quick walkthrough of creating the game Rock, Paper, Scissors in Python. So doing it from start to finish. We're looking at the creative process, building it up bit by bit, testing it, and also then see how we can leverage PyCharm Debugger to understand the logic of an application. And in the end, we'll end up with something like this, where we're playing rock, paper, scissors with a computer. So it's asking me to enter R for rock, or P for paper, or S for scissors. I'll enter R for rock. I lost because the computer played paper, so I'll try rock again. And computer played rock, so it's a draw. I'll play paper this time. And another draw. I'll try scissors. And I lost because the computer played rock. I'll play rock. And then let's quit. So I didn't do too well. I didn't win any. Drew 3 and lost 2, as you can see there. So this is essentially what the game is going to look like in the end. What I normally do is I start jotting down a few notes just so that I'm clear about what it is I'm supposed to do. So rock, paper, scissors. It may seem obvious, but that's what it is. We want 2 players, computer and player. So the computer player, we need to provide logic for that, which means we need to use random. So because we want to make sure that the computer can play rock, paper, scissors, but to do that, it has to be done in a random fashion. So we need to use random, and ideally then a list. So I want the random number to use as an index to a list of rock, paper, scissors. So I'll just do this. There we go. You also then want the player. In this case, though, we use input. So the user inputs rock, paper, scissors. We also need a list for that. And need to check who's the winner. So we need to compare computer and player and find the winner. That in a nutshell is what we need to do. So this just helps me keep in my mind clear what it is I need to do from a coding perspective. Now, first of all, as we're going to use a random function, we need to import the random library. So it's very easy to do import and random for the computer. So let's see, random, round int, there, first one. A random integer from 0 to 2. Why? Because I want to use as a pointer. We have a list which starts at 0, 1, 2. So rock is 0, paper is 1, scissors is 2. That's why I want a random integer. So let's make sure that this actually works. So I will put this in a print statement. Run it. Get a 1, run it again, get a 0, run it again, get a 0, run it again, get a 2. So I now know that that logic works. In other words, we can get a random integer from 0 to 2. So I can remove the print statement. I want to save this then. So I want to save it to computer for RPS variable. And again, just to make sure that that works, I can do a print statement computer RPS. I can run it, and I can see I get a 0, a 0, a 0, a 2, a 2, a 0, and a 1. So we now know that that logic works. So I can remove that print statement. However, since we're comparing rock, paper, scissors, I don't want it to be 0, 1, 2. So I want to create a list, a comparison list. We'll call this RPS underscore list for rock, paper, scissors list. And I want to put it before this. I'm going to use it for both. So the list is going to be a list of strings. The rock, we have paper, we have scissors. So that's the list. Now I want to point to that list. So what we need to do is we need RPS list, and we want to use computer RPS, so the random integer, as a pointer. So let's wrap that in a print statement just to make sure that that actually works as designed. So what I'll do is this, I'll add an additional print statement just to print the number. So what we have here is we're printing the random integer from 0 to 2, so 0, 1, 2. And then we're using that as an index to point to this list here. So let's run this. 0 is rock, good, that's correct. 0 is rock, 1 is paper, 1 is paper, 2 is scissors. So that works. I'm happy with that now. That means I don't need to print that again. I don't need that print statement. However, I want to save that. So I'm going to overwrite the variable there so that I just get rock, paper, scissors. So let's run this again. Paper, rock, paper, scissors. Good. So I can quickly see then that this is actually working the way I want it to work. I can remove that. Now, what we're going to do here is, let's say, just want to see how this works. I'm going to use a PyCharm Debugger. So what I do is I just select where I want the breakpoint. In other words, where do I want the application to stop, so that I can take a closer look at what happens. So it's going to run input random, and then it's going to stop there. I can right click and do debug scratch 3, and it runs and stops there. Now, I can then go through this. I can step through this or step over. So I click that. We can see that the RPS list, the variable, consists of rock, paper, scissors. That's good. You see that, length of 3. Then run the next step. You can see that we got a random number, which is 0. And that 0 should then point, if we do that, to, let's check the console. Oh yes, because I didn't do a print statement, that's why. So let's do this without a print statement. Computer, let's run this again. We get scissors, good. So let's do the debug. We have debug, so rock, paper, scissors is assigned to that variable. We get a random number of 1 this time, which is good. And to validate that, you can see that the debugger says, hey, computer underscore RPS variable is assigned the value of 1. Let's run it again. So computer RPS is then we use the pointer to paper. So it actually, the debugger says, yeah, okay, look at this. This is pointing to paper. And therefore, the computer RPS has the value of paper, which when we execute that, it prints it. Let's look at the console, and we see paper. I will just remove that breakpoint. So this is just a very simple way that the debugger can help us to understand the logic. And we're going to use this again a little further on just to see a more complex solution. The good thing here, though, is, so I can remove the print statement. The good thing here, though, is that now basically we're done with the logic for the computer playing rock, paper, scissors using the random integer function. So we've imported the random library. Why? Because we want to use the random randint function with the random integers of 0 to 2. So 0, 1, 2. I want to assign that to the variable computer underscore RPS. We then want to use that as an index for RPS list to point at 0, 1, 2, and save that. So overwrite the computer underscore RPS variable. So we get rock, paper, scissors, because those are the results we want. So we're done with the computer. Let's have a look at the player. We want input from the player. So let's do an input statement. And let's do please enter R for rock, for P for paper, for S for scissors, for Q to quit. And let's save this to a variable called player underscore RPS. Let's print player. So this way, just verify that it actually works. So let's right click and scratch. Please enter R for rock, P for paper, or S for scissors, or Q to quit. Okay, let's do Q. This is Q. Let's run it again. Let's do R. R works. Let's run it again. P. Yep. Let's run it again. S. Oh, sorry. If we run it again, and I do a capital S, it does that too. So I want to do something about that. And also, if I run it again and I enter or just stuff that shouldn't be there, it gets that as well. So I want to make a few changes. I want to make sure that I strip all white space before and after to make sure that I get the R or P or Q or S. What I also want to do is I want to make sure that everything is lowercase, so that when I do the comparisons, it's just easier to check. So in fact, I will actually put that print statement back again, run, and then a bunch of spaces, a capital R, print return, and we get the lowercase r. So I know then that this works as it should. Good. So we now have two things. We have the computer playing rock, paper, scissors. We have the player entering rock, paper, scissors. However, we're only entering the first letters. So we could either check R, whether that is the first letter of one of these three, or P is the first letter of one of these three, or whatever. But I think it's easier to do this. If player underscore RPS is equal to, let's do R, then I want player to be overwritten with the value rock. Else if player RPS, if it is not equal to R, check whether it's equal to P. If it is, then make sure that the player underscore RPS variable is paper. Else if player RPS is equal to S, then we want player RPS to be set to the value of scissors. Now, why are we doing this? Well, we're doing it so we can compare the computer's rock, paper, scissors with our rock, paper, scissors. The other thing we need to do as well is to check for Q, because obviously if I quit, all I want to do is exit. Another thing as well, if I enter something that is not an R, or a Q, or a P, or an S, in other words, gobbledygook, I want an else statement just to say, please try again. Let's do this as well. Let's put a print statement here and print player RPS. Let's run. I will enter R, rock, again, P, paper, again, S, scissors, let's run again, Q, let's run again, try again. Now know that this logic works together with the input statement. So what we've done here is we have two players. We have the computer player, we have the player providing input, and now we need to compare to see who's actually won. So let's just move this a moment. We need to check whether it's a draw, a win, or a loss. Now, how do we, well, the easy one then is actually draw, because if player RPS is the same as computer RPS, in other words, if both play rock, or both play paper, or both play scissors, it's a draw. So that's an easy one. Print. However, how do we check a win? So here's an interesting thing. There's an easy way, and what I'm going to do is I'm just going to create a list of the winning combinations. So I call it a win list, and it's going to contain the winning combinations. So rock will beat scissors. That's the list, in fact. Next one, we have paper beats rock. The third and final winning combination is scissors to beat paper. So those are the three possible winning combinations for me as a player. So if I have rock and computer plays scissors, I've won. If I have paper and computer plays rock, I've won. If I have scissors and the computer plays paper, I've also won. Anything else is a loss, or if they're both equal, as in here, it's a draw. So what I want to do here is, because I have a nested list, I want to have player, comma, computer in list. In other words, if these two are in this winning combination here, then I've, as a player, have won. So let's just print one. And then everything else. So if I haven't drawn and I haven't won, I've lost. So essentially just do this, print, lost. We'll make sure though that this actually, so actually is correct. So the print statement of player underscore RPS, comma, computer RPS. So I can see what we've both played. And let's run this. So I will enter R for rock. I played rock, computer played paper, so I lost. Let's try again. I play rock again, computer plays paper, I lost. Okay, so I'll play paper this time. Computer plays rock, I won. Yes. Finally. So we now know that this logic works. Okay. What we can do now is, before we add further code, which we will in a moment, we can actually step through this. So let's put a breakpoint here. Let's right click. Let's do debug scratch 3. I will enter R. That's not a good place to do it. Sorry, do that there instead. Apologies. Debug. There we go. So we have win list. Let's step into that. So it's now assigned the winning list to the win list variable. It's now assigned the rock, paper, scissors list to the variable. And now the computer is doing its random number, and the random number is 0. It is using that as an index. If we hover over that, we see rock is 0, and we can see the computer is telling us here that computer RPS is now rock. We're now going to ask the user for input. So I'll go to the console, and I know the computer played rock, so I'm going to cheat and do P for paper. So back to the debugger. Computer played rock, I have P. So we check first if player RPS is rock. It's not. We hover over that and see that it says P. So is it P? Yes. P is equal to P. Therefore, player is now set to paper. So the variables here are player is paper and computer is rock. They do not equal one another, so it's not a draw. And then we have player, paper, and computer rock. So paper, comma, rock in win list. Do we have, yes, there we go. Paper, comma, rock is in the win list. So let's do this, 1, and that's the end of it. So just remove that. We've just gone through the logic. We've used the debugger. We can see that everything is working as it should. However, we're not done. We want to add a few additional things to this. Well, first of all, we want to make sure that we keep on playing until we enter quit. So we want to have a while loop. What we do then is, I know that we need to enter the while loop here. So while player for RPS not equal Q, and we execute it. Now we can see that the player RPS hasn't been defined because it's defined later on. So we'll do this. layer underscore RPS is a string. So we'll just do that, and it's happy. It also means we have to indent all of this code here. So I've selected all, press tab, and in theory, then this should work. So let's right click, run scratch. I'm just going to try gobbledygook first. Please try again. There's an error here. I can see a logic because it prints lost. That's fine. We can fix that. Sorry, I forgot. We can do R1, P, draw, S, draw, S, draw, S, draw, S1. So, and then Q. There's a bit of a problem here though. It printed this. And that's because once I got to Q, once I got to here, print again, what I want to do is I don't want to execute this block, so I need to add a continue statement. This will then ensure that we go back to the start of the while loop. So let's test this again. Let's just enter rubbish. Please try again. Good. Back to the while loop. So that's working okay. Now, there are a couple of things as well I'd like to add to this. I want a bit of some statistics. I want to see, count up the wins, the draws, and the losses. What we can do here is we can do draw plus, sorry, I'm using a Swedish keyboard, plus equals 1. Now I have to define that variable, so let's do this. Up here, I have draw equals win equals loss equals 0. Now I could just enter draw equals 0, win equals 0, and loss equals 0 in separate lines. This is just shorter, easier. So we now define draw. So what this does is, this is the same as typing draw equals draw plus 1. However, it's niftier just to do that. We want the same then for win. So win plus equals 1. And then lost, we want loss plus equals 1. I want to print these. So we can either print them, initially we can print them here, just for the fun of it. So print statistics. So in. Now what I want to do is I want to use the F strings. So we'll use curly braces here, called win. Draw. Variable draw. Loss. Variable loss. And if we now run this, stop and rerun, R1, 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 lost, 1, P, that's Q. So I won 6, drew 0, lost 2. So pretty decent. Now, ideally though, I'd like to expand these to print something nicer. For example, draw, and just say player played. This is that string as well. Player played. We have player RPS and computer played computer RPS. I'm going to just copy and paste that. And change this so that it says 1. Player played. So draw. I want a face. I won. I want a smiley. And then here, lost. I want a sad face. Okay, let's put it again. R, lost. I played rock, computer played paper. P, a draw, both did paper. S, a draw. S, a draw. P, a draw. Rock, I lost. And then Q to quit. Drew 4, lost 2. Now we could make a change to this. So this is, we could say that this is done and dusted and we're happy. There are a couple of improvements. We could change this code so that the computer plays against itself, or that two players can play against one another, or maybe even to make it more complex, have several players play against one another. So the logic then we'd have to see, if I play rock, someone else played paper, and someone else played scissors, I'd win over the scissors, but I'd lose against the paper. So we'd have to write the logic to do that. There's a few simple things here. For example, when we're playing, we may want continuous statistics. So now I provide the statistics at the end of the round. Notice when I press quit. But I want to move this then all the way down to here at the end, because I want this to be a part of, sorry, there we go. I want this to be printed every time we play. So let's try this now. I play rock, I won one. I play P, I won one, lost one. I play S, I drew. And Q to quit. There is another thing as well. One of the things you'll notice is that the computer is referencing this list for rock, paper, scissors. And then here I've hard-coded the input to the user. But let's say I want to change it. Let's say I want to add this to represent rock, square brackets to represent paper, sheet of paper, and I want the characters, lowercase characters of E and B to represent a pair of scissors. Now, when I compare those, this won't work because this is rock, this is paper, this is scissors. If we run this now, I play rock, it says lost. Again. So what's going to happen is it's going to continue. I'm going to lose everything because it compares rock, paper, scissors with rock and the additional signs that I've added just to kind of clarify. So here it would actually make more sense to use the RPS list 0, so the point to R for rock. Here I want to use the RPS list, and sorry, 1. Here the RPS list and 2. This points to rock. This points to paper, and this points to scissors. Now let's run this again. Stop and rerun. R, draw. P, I lost. S, I drew. So now it's actually working as planned. So this is just kind of a couple of simple things. Now, one thing that I recommend is to just understand the full flow of this is, let's do it right this time. So I'll put a breakpoint here. Let's use a Pytron debugger just to go through step by step to see what actually happens. So I'll right click and I'll do debug. Now, at the moment, there are a few special things that the computer does for us. We can ignore that in a moment. So let's just step over this. First of all, we create the win list. Then we create the rock, paper, scissors list. So we see, assign to the variables. We assign where the play RPS now is just set to an empty. And what we can see the debugger does is actually says, well, play RPS is an empty string, which is good. It's a string variable. Win list has, the variable has these values. The RPS list has these values. Let's continue. And then we can see draw, win, loss. They're all equal to the integer 0. And now we get to the while statement. So we run the while statement. That's fine. We have a random number. So the random number is 2. That is used then to point to scissors and the little special character, or because I have DB there. That's just kind of to signify that it's scissors. So that is now what is in, if we hover over this, is the computer underscore RPS variable. And if we look down here, we can see, yeah, scissors. Now we're asking for input, so execute that. We have to go to the console. Now I know the computer played scissors, so but I'll be fair and I'll play paper to lose. Let's go back to debugger. So I entered a P, you see there. We check to see, is P equal to R? No, it's not. Is P equal to P? Yes, it is. Therefore, we set the player RPS value, variable, to, if you hover over that, it's now paper. And once that's done, we have a look to make the comparisons between what the computer played and I played. So we have player RPS is paper and computer RPS is scissors. Are they equal? Are they the same? No, they're not. Therefore, this is not a draw. And then it checks, is the combination of paper, scissors, in the win list. Paper, scissors. No, it's not, because it's not a winning combination. So therefore, it's a loss. And what we do here is, if we look at the variable loss is 0, when I execute this, loss is equal to 1. And we print a statement to say, you lost. And then let's go to the console. So it says, lost, player played paper, and computer played scissors. Go back to the debugger. We step over, we have a look at the final statement there. Statistics, win 0, draw 0, loss 1. And it continues. So we can just step through this time and time again. Computer plays the 1, and it is paper. This time, though, I'm just going to quit. I'm going to console, I'm going to type Q for quit. And then when we go back to the debugger, so it's not R, it's not P, it's not S, it's Q, execute exit, and finishes the program. So that's it in a nutshell. I can remove that breakpoint. So I hope it just gives me a few ideas, understanding of the thought process, the logic behind this application, and how we build the application bit by bit. So essentially, programming is taking a big problem, breaking it into a number of smaller problems, solving those smaller problems, thereby solving the bigger problem. And we've also covered, so now the simplicity using the random library, creating this wonderful application, and had a close look at the PyCharm Debugger. And I hope this is of interest. Okay, take care. Bye-bye.